Hey, I'm Jonathan, and I wanted to share with you something really exciting we've been working on at Apollo recently. As applications scale, and as AI accelerates that scaling, we need new tools to power the increasing number of APIs, or our API layer. And to do this, we've built the Apollo GraphOS Operator. It makes it really easy to deploy federated APIs in Kubernetes, which means you can get up and running really fast. You can also monitor and manage your deployments, automate common tasks, and adopt new features as you need them. So before I show you what it's like to use the operator, here's what that actually looks like at an architectural level. The orange boxes here represent custom resources that we've added to Kubernetes so that we can treat Apollo objects as though they were Kubernetes objects. So if you imagine what happens when you push a subgraph change, and that's just a word that we use to refer to the individual services that make up a federated API, you would push a new version of the subgraph. The supergraph schema, it's essentially just a description of which of the subgraphs you want to be in your federated API, would then pick up that a change has been made and route a composition request into Apollo Studio. That would do the composition, and then the supergraph, and that's a description of what you want the fleet of routers to look like that actually routes traffic into that supergraph schema, would pick up the new version of the schema and redeploy the router fleet so that it's then serving that new schema. And all of that happens without any of the manual integrations or custom written scripts, all the back and forth with Studio you sometimes have to do in order to orchestrate all of this properly. Developers of these individual services can focus on developing while the deployment of the whole graph just takes care of itself. So let's dive into actually using the operator and let's get it installed and up and running. The first thing we need to do is generate a key using Rover. So we're going to use a new Rover command, which is Rover API keys, and that will allow us to create a new kind of API key, which is an operator key, and that has the ability to address any graph within an organization. Now that we have the key, we need to put that into our Kubernetes cluster so that the operator can actually address it. So we do kubectl create secret, generic, and then we're going to use from literal in order to just be able to copy and paste a string into there, which is the API key, and we're going to call it Apollo API key. And so as you can see now, we've got Apollo API key created. Now I'm going to copy and paste in this command, but all that we're essentially doing is a Helm install of our Apollo operator Helm chart, and we're giving it the name of the secret that we just made in the previous step. And so if we run that, we can then see that we get our operator installed at the version that we want it to. So if we look at this supergraph resource by doing a cat command, you can see that it's got a couple of different sections in it. The first part is the number of replicas, so the number of routers that you actually want to spin up to serve traffic, some special config for the router, and then just a couple of other bits that include things like the version of the router you want to run, and in this case, the graphref in Studio that we want to point at. There are many other options you can add under this schema key here, but actually, in this case, we're just going to point it at an existing graphref that we have in Studio. Now, if we apply this to the cluster using kubectl apply, we can see that we have created a supergraph. And what that will then allow us to do is to route requests to the routers that are powering that supergraph. Yeah, there we go. If we now move to Apollo Sandbox, and this is just a really simple way of sending requests to our fleet of routers, we can actually prove that we've deployed them properly and that they are serving traffic in the way that we'd expect. So let's construct a query in this operations box here by say we want to look for a specific order, we want to include the buyer's ID, and we also want to include the items within that order and their specific IDs. So we want to look for order number 1 specifically, and we then issue that query. We then see that we get a response back from the router which is sensible and includes the data from the supergraph that we've deployed. So using only 3 commands, we've managed to deploy a fleet of routers that can accept external traffic into the cluster. But that's a simple example. What if things are a bit more complicated? In this second example, we're going to be using some of the similar concepts to that we used in the first example, but using slightly different components. So the first thing we can look at is this product subgraph. So if we run this cat command, then we can see this custom resource here. There's basically 2 things that are interesting here. The endpoint is pointing at a REST service that's running outside of the cluster. And then the schema is a connectors schema. And connectors is just something that we use within Apollo in order to treat REST APIs in the same way that we treat GraphQL APIs. This subgraph has the schema embedded inside of it. And if we now look at our reviews subgraph, this one still has an endpoint, but it also has a schema that's looking at an OCI image. These are essentially packages of data that are put into a specific format that can be read by any container runtime. So what we're doing here is we're actually extracting the schema that we need from inside of the same Docker image that's actually running the GraphQL service that's providing our reviews. And there are many ways that you can configure your subgraphs if that's something that you want to do. So if we apply these two to the cluster by running two different apply commands, so first one for reviews, and then the second one for products, we can look at a resource to link them together, which is the supergraph schema. So if we look at the supergraph schema, we can see that this is fairly simple. It contains two things that are relevant. So the first one is the GraphRef, and this is basically just a way of pointing at a particular graph variant in Studio. And then we have the selectors, and this is essentially saying, look at all of the subgraphs you can see, and the ones I want to be included in my schema are all the ones that have a label with key domain and value retail. And so this is a good way of separating your subgraphs if you have lots of them, but you only want to include some of them in your supergraph or your federated API. So we can apply that to the cluster using another simple apply command. And then if we use another cat command, we can have a look at our supergraph. So this is very similar to the one that we used in the first example, but the most important difference is that the schema is now referring to a resource, which is the supergraph schema that we defined just a few moments ago. And so now, if we apply this to the cluster, what will start to happen is that the cluster will start to spin up router pods that have the federated API schema that the supergraph schema defined via the use of its labels. If we now jump over to Sandbox, we can start to issue queries like we did before. So let's say that we want to query products, and we want to get their descriptions, and we want a list of the bodies of the reviews that are associated with them. And so if we look for product number 1, then we see that we get back what we expect, a description of the product and all of the reviews associated with it. The composition has occurred between the subgraphs we mentioned, and this has been deployed into the fleet so that we can actually access it. There are even more advanced features that you can use as and when you need them, and we have all of those in our documentation. So that's the Apollo GraphOS Operator, a completely new way to manage Apollo resources, but all powered by Kubernetes. And the real magic here is that using the operator allows teams to focus on shipping new customer experiences, rather than worrying about integrations and infrastructure. Why not try it out for yourself and download it?